When I talk about geomorphic processes, this is something very commonly used and a chapter in your NCERT. Diastrophic and sudden. Under sudden, you have the volcanic eruptions and the earthquakes. Under the diastrophic, you have two major phenomena or processes, epirogenetic, other is orogenetic. This is a plate. Another plate has come from here and a pressure has been exerted. So do you realize this pressure will exert and lead to this? Do you realize this is a fold that has been created? This is a fold. Why? Because of the compressional forces taking place. Any movement that is associated of the weathered rock under the influence of gravity is mass movement or mass wasting. Hello aspirants, welcome to PW Only IAS. I am here Harpreet Singh with another lecture from the NCERT series of physical geography. Today is the lecture number 5, that is geomorphic processes. Please understand this is a very critical and an important topic for your preliminary as well as your mains examinations. Whatever you have done or learned till now, like topics like continental drift, plate tectonics and its types and everything related to that will be utilized over here, because this is a very critical topic with respect to the applications of the topic that you have done previously. So I would request you to please go through the previous videos in order to better understand this topic. Now, please have your A4 sheets along with you. While I'm teaching you, please note down whatever is being taught here. I have used extensively a lot of flowcharts, handmade diagrams, and a lot of figures that will be very useful for your understanding. Now, while I'm explaining to you, please focus, note down, pause the video wherever it is required. If required, you can again replay the video to understand it better. Sometimes you might miss certain things that leads to misunderstanding of certain topics. So you can go through the video and again if you do not understand. Otherwise, most of the topics will be clear while you are going through this video. Now let's begin with the lecture number 5, that is geomorphic processes. This is my Telegram account where you can find the link of this particular PDF after the video has been posted. Along with it, you will find a lot of content on geography, anthropology optional, society and civil services preparation in general. So you can subscribe to this particular channel. Now, when I talk about geomorphic processes, this is something very commonly used and a chapter in your NCERT. Now the question arises, what is this basic term? So please understand this thing. This question has been asked multiple times in various civil services examination, whether it is by UPSC or by the state services, in the preliminary examinations also and in the mains examination. Its application also becomes really very important here. Now see, when I say geomorphic processes, we will be understanding this and then we will be classifying also. So please, while I'm explaining you, be on your toes and keep on noting it down also and understanding it. These are natural physical processes that create, very important thing, that create, modify and destroy landforms on the Earth's surface through the action of weathering, erosion, transportation and deposition. There are so many terms here. Every single term is important here and every single term is going to be taught to you. Please remember, the topic of transportation, topic of erosion, transportation and deposition will be done in the next chapter, that is erosion. We'll be having a brief understanding in this topic. Our focus majorly will be weathering and mass wasting here, right, as given in the NCERT also. So overall, but what you need to understand is, let us say there is a landform, any landform, any part on the surface of the, let us say the crust, you will be seeing that it is going to undergo various erosional processes. Right? Erosion by possibly river, erosion by glaciers, erosion by wind. Now, do you realize that these are processes that are eroding those landforms that are present on the surface of the earth, right? Now, these processes are in a way destroying the landform. Yes, they are destroying. But there is another process or another processes that are going on, like volcanic eruptions. Now, these volcanic eruptions are creating new land masses also, landforms also. So, do you realize there is a competition going on between the processes that are creating the landforms and the ones that are destroying? And this is a balance that is maintained by the earth. You have done in the plate tectonics also, when there are, let us say, divergence of the plates that are taking place, again, new, according to the phenomenon of seafloor spreading, new crusts are being formed. On the other hand, the other crust on the other side is basically subducting inside the mantle and getting destroyed. So over there also you see construction and destruction processes taking place. Similarly, if you see on the earth also, there are a lot of processes which are destroying the landforms and there are others that are creating the landforms. So these processes combined in a way come under the category of the geomorphic processes. That is why you see geomorphic processes are natural physical processes that create, let us say, all those phenomena and processes that are taking place that are creating a landform, or let us say modifying. Now you see there are processes which are eroding, that means they're modifying possibly the shape also, size also, and in a way in a later stage can destroy it also. So destroy the landforms also. And what are the processes that are going on associated with them? Weathering, erosion, transportation, deposition, and all these things are going on. So these are, or this word or this definition basically refers to the what? Geomorphic processes. Now geomorphic process, if I want to understand better, we can classify two major terminologies under this. Two major terminologies. First, the geomorphic processes encompasses both the endogenic processes. What do you mean by endogenic? We'll be doing everything. Don't need to worry about that. Right now, just understand, I have all the charts in front of me. We'll be understanding all of these. Geomorphic process basically includes or encompasses two broad processes. First, the endogenic. What do you mean by endo? That is inside. So what does it mean? Operate inside the earth. Now, for example, the earthquake is taking place. You have already done earthquake in a lot of detail when we were doing the concept of P waves, S waves. I've explained you. Now, this is a phenomenon that is taking place inside the earth. Similarly, volcanic eruptions also, the magma is coming from inside the earth. So, you see there are several processes that operate inside the earth. Those are basically referred to as endogenic processes. On the other hand, there are other processes like erosion by, let us assume, erosion taking place by river water, erosion taking place by glaciers, erosion taking place by wind, and so on and so forth. Now, these are taking place on the surface of the earth. That is why these exogenic, exo means outside. So, exo means outside. Endo means inside. Operate on the surface of the earth. So endogenic and exogenic process. These processes, they maintain a balance, and these processes together combine to form a whole process that is a major process, that is geomorphic processes. Clear? Now, having understood a little bit about geomorphic processes, having understood what is a little bit endogenic and exogenic, now let us go a little bit into detail. Now, please understand, every time, or even I have also come across students who say, sir, when we talk about endogenic, is that the only word that is basically used for that? No. Now, please understand this very well. Various standard books, various thinkers have used different terminologies. Endogenic is one term. It can also be called by endogenetic. Some thinkers have used this also. It can also be known as hypogenic. So in the examination, possibly if they use some other word, you might get confused at possibly how this word has come. Many people think, no, it is not endogenic, it is endogenic. Please understand, these are standard terminologies. You might have read one or the other word, but these are ones which are present in various standard books, and the foreign authors have also mentioned. So I mention it here so that you should be aware of it, because UPSC might test you on them. If they mention hypogenic, possibly you will get confused. So endogenic, or hypogenic means one and the same thing over here, broadly, when you understand them. Similarly, exogenic, or epigenic over here will mean the same thing. We'll be considering this later on. Let's see the classification first of all here. Now, if you see endogenic, or hypogenic, we have classified them into two broad categories. First, diastrophic. Second, sudden. Let us see this chart and then we'll analyze it. Diastrophic and sudden. Under sudden, you have the volcanic eruptions and the earthquakes. So these are all taking place inside the earth, right? Not on the surface, inside. Some processes that are going on inside the earth. That is why we have said the processes that operate inside the earth, right? Under the diastrophic, you have two major phenomena of processes, epirogenetic. Under epirogenetic, you have emergence and submergence. Other is orogenetic, under which you have tensional forces and compressional forces. Now, you would be asking me, sir, you have given us so many terminologies. These terminologies themselves are so difficult to comprehend and understand. So, what are they? Absolutely, you don't need to worry about them. We are there to explain you these things. Important is you note this chart first of all, and then possibly you will be in a better condition to understand it also. Please note this down. Pause the video and note it down, right? Now, let us move further to understand each and every terminology that is present here. When I talk about sudden, first of all, if we are talking about the phenomena, endogenic, and hypogenic, it basically means processes taking place inside the earth. This is the first thing that you should be aware of. Now, when I talk about sudden, please understand one thing very clearly. The classification, this diastrophic and sudden, is based on the fact that sudden phenomena, that means those processes which take place at a very fast pace or a rapid pace or take place suddenly. Diastrophic forces are those forces or processes that are basically taking place inside, but they are basically very time consuming processes or take a lot of time. So, under sudden, you can say these processes or phenomena, these processes take place at a very rapid pace. You yourself know that the moment earthquake comes, you are not even able to detect it, let us say 1 hour prior to that the earthquake is going to happen. It's very difficult. So these are very sudden. Similar volcanic eruptions also, these are very sudden processes. These are very processes that happen very quickly. On the other hand, if you see other processes like, let us say, mountain building processes or rise of the continents because of the internal forces, these are time-taking processes. These will take a lot of time. So that is why sudden are these processes that take place at a very rapid pace. Under them, we have done earthquakes and the volcanic eruptions. Volcanic landforms will be done in the chapter of landforms. Otherwise, you have done the volcanic bodies also, right? What are present inside the earth crust. We have done lapolith, locolith, batholith, all those things have already been done. Types of volcanoes will be done in the landform chapter next. So we have already majorly done these. Earthquakes we've already done in a lot of detail when we were doing or studying the interior of the earth. Now, when I come to the diastrophic forces, diastrophic processes, please understand. First thing is important is these are time consuming processes. They take a relatively much longer time. So what is more important here? Time taking, take a lot of time. It is not like in few seconds you have new mountain building. It doesn't work like that because you have seen the plate tectonics movement also. When the plates are moving, they are moving at a very slow pace, very minimalistic pace, few millimeters in a year. Now in that processes, you cannot have a mountain building taking place in few seconds. It will take a lot of time. Similarly, continents emerging or submerging is also a time-taking process. That is why diastrophics are those processes which take a lot of time. Both vertical and horizontal movement are caused due to the forces deep within the earth. So it involves forces which might be horizontal, which might be vertical also. So we'll be seeing that. We'll be seeing the aspects associated with the faults, folds. I'll be considering those things also. Please note this very well. Your NCERT does not cover in detail about what are the folds, what are the types, what are the faults, what are the types. Those are not covered. And I'm covering those concepts in this particular chapter itself. Why? Because UPSC can very well ask you this because it is an integral part of your chapter, but NCERT does not cover it. So all the diagrams, all the definitions are going to be mentioned here. I'm just going to show you an example here. These folds I've already drawn. These are not mentioned in your NCERTs. All the types of folds, all the types of faults, I've already done this. So you should take it as a resource where you can rely on. You can copy the content also while listening to the lecture, and with respect to fault and folds and other parts, it will be more than sufficient. Okay. So it involves basically both the vertical and the horizontal movement. More importantly, it is a relatively time-taking process, unlike the sudden. Now, under the diastrophic, You have two categorizations. First is aperogenetic and other is orogenetic. Now, aperogenetic has two processes, that is emergence or submergence. Let us see one by one. When I talk about aperogenetic movements of forces, please understand the word apero means continent. Genetic means origin. That means they are talking about the concept of the origin of continents. Now, the origin of continents through various processes which we study is a very long or a time-taking process. Now, there are two phenomena that can happen. Supposingly, there is emergence of land because of the internal forces. That is known as emergence or upward movement. So, emergence of large continental masses, that is the upward movement that take place. We will be seeing these phenomena when we will be going further in the chapter, so don't need to worry them. Other is submergence. Submergence, that means the continental mass basically submerged. So, that means there is downward movement that is taking place. So, over here, whenever we talk about the aperogenetic movement of forces, we are talking about very huge land masses, continental size. That is why this is again a very time-taking process. Now, this is aperogenetic movement. If we move on to the other part, orogenetic movement. Now, please understand, the moment I talked about orogenetic, orogen basically means mountain, genetic means origin. Now, these processes, please understand, basically talk about mountain building processes. Now, you have already dealt with these chapter or little bit about these details when we were doing plate tectonics. You would have remembered that when we are talking about various types of mountains also, you had understood about the young fold mountains, fault mountains also. We have studied a lot about them. So, let's take an example here. Let's see, this is a Eurasian plate. This is the Indian plate. Now, this is one of the methodologies through which mountain building processes basically happen. I'm giving you this example because various processes through which mountain can be built, some of them have been studied in plate tectonics, other will be studied through the concept of folding and faulting, which we are going to do after this, right? Now, do you realize this is the Indian plate which is moving towards the Eurasian plate. You know that very well, right? So, we had the Tethys Sea also. We will be seeing that also, don't worry. Now, slowly what happens later on, this plate basically subducts. Subducts under the Eurasian plate. Obviously, you realize that there is going to be a lot of force that is exerted that will lead to this part rising. Why? Because force is being exerted here. Now, the question will come, sir, has volcanic eruptions or evidences of volcanic eruption present here? You will see minimalistic. There's a reason behind it, because sometimes when the crust is very deep, in that case, you do not very frequently see volcanic eruptions when there is subduction taking place. Please understand this very well. That is why you do not see as such volcanic eruptions over here, because the crustal part over here itself is very deep, right? So, what has happened is, because of the compressional forces that is being exerted, it leads to this folds or bending of this particular plate. Now, you see, this phenomena that has taken place has not taken place in few minutes or few seconds. It has taken millions of years. There have been a lot of stages. That is why you see the Great Himalayas, the Middle Himalayas, and the Shivaliks. So, these origination of these have been basically taking place because of the various subductional phases that has taken place. That is why this is a way which you see a possible phenomena through which mountains can originate. Yes or no? right? So again, similarly, there are a lot of mountains that basically originate because of the faults also, right? Now the important question will come, sir, what are faults? Now, please, that is why I'm telling you, you will have to wait for another 15-20 minutes. When we go to the topic of fold and faults, then you will be better able to understand what is the concept of mountain building also. Because if I explain you through the fault mechanism, you should know what is fault, which we will be doing in the coming few minutes. So when we will be doing faults, I will tell you, see, this is an example which you can see in various mountains like Vindhyan range and all, how they are formed. What is the example? So we'll be doing that. You need to wait for a few minutes, right? So what I'm trying to say is various phenomena, either through faulting, either through folding, a lot of mechanisms through which mountains are being originated. These are not processes that are taking place or happening in few seconds or minutes. This is taking a lot of time. That is why when we are talking about orogenetic, you see these are time-taking processes. Now the question comes, you have written, sir, tensional forces and compressional forces. Now see, what do you mean by tensional forces? When I talk about tensional forces and compressional forces, these are two phenomena. Now see, over here, when let us say two plates are moving towards each other, or even one plate is moving, do you realize this movement is basically leading to compression. Compressional forces means that the distance between two bodies is decreasing. If one is stagnant and the other is moving, other is moving, then also you realize the distance between those entities in a way is decreasing. So it will lead to compression, yes or no? Or if both the bodies of plates are moving towards each other, then also compression is taking place. So this moving towards each other is basically referred to as a compressional force. Now there can be an instance where, let us assume, there is, let us say, tensional or diverging forces. Let us assume this. Let us assume this. Supposingly, for just a minute to understand the fault, let us assume there are certain cracks present here, right? Cracks. This is diverging, this is diverging. Now, do you realize due to this, it is possible that this might move down? Yes or no? Yes or no? These are the phenomena through which rift valleys are also formed. There are a lot of processes through which even faulting also, through which mountain building can take place. Those are known as, again, fault mountains. So that is why, please understand, this is a reason which has arisen. Similarly, let us say there is a rift valley over here also. So now this is a risen part. That is why, due to faulting also, you can possibly assume or see that phenomena of mountain building can be observed. Obviously, you will see those are not very tall because there is divergence taking place. But in a also way, we should understand that compressional forces obviously are creating the huge mountains that are present here, because obviously it is decreasing the distance and more energy is basically being thrusted over here. So that is why the compressional forces lead to creation of very tall mountains also, right? Okay, so we'll be doing these things later on, don't need to worry. We'll be understanding when we'll be faulting. Just a basic understanding of the orogenetic movement. Orogenetic movement, what do you mean by now? These are basically forces of movements which deal with the origin of the mountains. Clear? Now let's come back here. Before we begin the explanation of what is folds and faults under the compressional forces and the tensional forces dimension, we should have a basic instance and representation what is coming under the exogenic processes. We have done till now endogenic and endogenetic processes under this diagram. See here, we have done all these things under the endogenetic and exogenic processes over here. We'll be doing the faults and faults. Just before we go to those topics, let us understand what comes under this topic also. Under the exogenic processes comes the weathering, which is physical, chemical, and biological. We'll be doing them. mass movement that is basically taking place under the force of gravity. We'll be understanding those concepts like slow movement, rapid movement, very rapid movement. Then comes erosion. Erosion can take place due to running water, groundwater, glaciers, waves, currents, and winds. Similarly, these geomorphic agents also deposit the things that they have eroded. So they are also they have the depositional aspects also. For example, the running water if depositing, that leads to the formation of a delta. So please understand this very well, that over here these are erosional agents also, geomorphic agents also, and depositional features also, which are depositing a lot of things, which we will be studying in the next chapter. Please understand this. These two things, as given in the NCERT, will be covered in the next chapter of landforms, because every geomorphic agent over here is creating certain landform. So that has to be studied very well. Erosional landforms, depositional landforms, so that will be considered separately in the chapter of landform as per the NCERT, right? Okay, now focus will be here when we will be doing endogenetic. Let's come back. Now let us understand the concept of folds and faults, which is not mentioned in your NCERT. Let me take an example over here. See, supposingly this is a plate, right? This is a plate. Another plate has come from here and a pressure has been exerted. So do you realize this pressure will exert and lead to this structure? Do you realize this is a fold that has been created? This is a fold. Why? Because of the compressional forces taking place. Now, this is a simple phenomena. If you understand, this takes place with these crustal layers also. So if this plate or crustal part, the force is exerted from one side, and this is, let us say, stagnant. Let us assume this. So it will lead to creation of this fold, this fold that is formed. So this is what? A fold, as you have already known. Now see here, waves like bends. What are folds? Folds are basically wave-like bends in the crustal rocks due to the compressional forces. Compression is taking place, as I mentioned, resulting in horizontal movement caused by endogenetic forces originating from deep within the earth. See, you know that you've already done the plate tectonics also. You have done the continental drift theory concept also. You have done the convectional current theory concept also, convectional current through Arthur Holmes, where we have already mentioned that a lot of phenomena are taking place inside the earth, which is leading to the movement of the plates. These are what? Endogenic processes, and these endogenic processes are then leading to formation of these what? Bending of these or crustal bending of these crustal layers, as I've shown you using the paper also. So these are bend or wave-like bends that are formed in the crustal rocks due to what? The compressional forces. I've already highlighted the keywords over here. Please remember, resulting from the horizontal movement caused by the endogenic processes that are taking place inside the earth, deep within the earth, and such bends are known as faults. So what are these bends? These bends are folds. Now, please copy this statement. This is a basic and the most easiest definition that you can come across with respect to folds. Let us analyze certain things regarding this. Whenever a fold is present, there will always be a, see, these are the limbs. If you see this, let me take an example. If I divide this into this form, this is one limb. Let us say this is a fold, this is one limb, this is another limb. First thing, you should understand the limb. So this part is one limb of a fold, this is another limb, right? Okay. Now if you see the structure, you will see certain parts have risen, right? And other part is again bending or downfolded. This part which is upfolded or arch-like is known as anticline. This part which is what? Let me take another color so that you will be able to understand it better. This. Okay. This part is what? Upfolded rock strata in an arch-like form. This part is known as anticline. The one which is downfolded, this part, downfolded part like a trough, is known as syncline. Always remember this. because this is very, very important. This has been asked in your preliminary examination multiple times, and in the PCS examination almost after 1 year, after every alternative year, they'll ask this question. In every PCS almost, because this is one of the basic concepts of the geomorphic processes associated with folding. Now, when you see the arch-like structure, how will you remember it? A for arch, A for anticline. The moment you remember this, you will never forget it. Arch means something that is upfolded like this. A for arch, A for anticline. Obviously, the other one will be syncline, which is downfolded. Clear? Now, let's move ahead. What are the types of folds that are present? Now, with every fold, I have drawn a diagram because, again, the NCERT does not mention it. And that is what is a missing part in your NCERT also, but it is something very important for you to understand. Now, these bendings can take place in various ways, depending upon what is the nature of the rocks, what are the, let us say, what are the forces, or to what extent the forces are being exerted. A lot of things basically matter here. So, symmetric folds. Now, symmetric fold, let us see, first of all, both limbs, you know what are the limbs? These are the limbs. So, over here, you see this is one limb, this is another limb. Both limbs bend equally and dip at the same angle away from the center. So, in a way, can I say, let us say this is a line, this angle and this angle is same. So, that means this is known as a symmetric fold. So, this is symmetric. If this angle is not same, it will be asymmetric. Let us see over here, this angle is different from this angle. So, when both limbs are not bent equally, then it is asymmetrical. If they are bent equally with a similar angle, then it is known as what? A symmetric fold. Next, monoclinal fold. Monoclinal fold. Now see, it is a bend in the otherwise horizontal rock layer where the layer tilt in one direction like a step. Now, it was otherwise horizontal, but the force it is exerted that it is formed like a step. So, this is known as a monoclinal fold. Now, this is almost like 90 degree. This is what? Almost like, this is what? 90 degree. Almost. I won't say completely, but NCERT also mentions that this is almost like close to 90 degree. This is known as monoclinal fold. So, a step-like structure is formed. Otherwise, what was straight? A simple, let us say, layer of horizontal rock. Due to the pressure being exerted, it has modified and bended in such a way that it has formed like a step-like structure, which this angle is also almost approximately 90 degrees. So, that is why this is known as a monoclinal fold. Very important. This has been asked multiple times in your PCS examinations also, and becomes important because this is something that many people don't understand. That is why I have drawn the diagrams. So, this is for the symmetric, this is for the asymmetric, this is for the monoclinal diagram. Okay, let's move ahead. Isoclinal, the most important thing, very easy. Here the limbs of the folds become parallel but not horizontal. These two limbs are almost parallel, but they are not horizontal. That means they are not lying down on the plane surface, right? They are parallel. This is known as isoclinal fold. If I turn this fold horizontally, that means the two arms are parallel as well as horizontal with the surface, then it will be known as a recumbent fold. Where limbs of the folds become parallel as well as horizontal, then it is known as a recumbent fold. Next comes overturned fold. Now, because of the compressional forces that are being exerted, what happens is sometimes one limb of the fold is thrust upon. One limb of the fold will be thrust upon along this plane on the other limb. Due to the intense compressional forces, this is known as overthrusting or overturn. So, what happens is, this was otherwise like this, let us assume. Further pressure is being exerted and this part is thrust on the lower, let us the other arm. So, this is known as the overturned fold. Now, next move ahead. Open fold. See, here the angle between two limbs is basically what? An obtuse angle. Closed fold is one where the angle is acute, that is less than 90 degree. Simple. Nappy. Now, nappy, please remember what is there. You have just now studied the overturned fold. What happens if after the overturn and the thrusting that has taken place, let us say the upper let us say this upper part limb is further exerted a lot of pressure, and this part moves, let us say, a lot of kilometers away from the other limb. This upper part will be known as a nappy. This upper part will be known as a nappy. See here, due to the continued horizontal and compressional forces, the broken limb, this broken limb is thrown several kilometers away. This was the original place, it has moved several kilometers away from the original place. This broken limb is known as nappy, not the complete structure. Remember that very well. This is known as nappy. Clear? These are what? Folds. Now you can yourself understand when there is collision of the various plates that are taking place. That is why you see various shapes, various types of mountain ranges being formed, because it depends upon the nature, the forces, the extent to which the forces are being exerted. So this becomes again very, very important over here, right? Okay. Now comes crustal fracture. We have done with the folding. Now let us come to crustal fracture, under which we are going to study the faults, right? See. Now see, let us take, it refers to the displacement of rocks along the plane due to tensional and compressional forces, either horizontally or vertically. Now, when I talk about fracture, the moment I talk about fracture, what do you see? Let us assume this. Let us see this. Supposingly this is a block. This is a block of mountain, right? There are certain compressional and tensional forces being exerted. You know what are compressional? That means compression is taking place. Tensional, that means divergence forcing taking place. Now, because of this, you can realize that there might be a case where, let us assume, there is certain crack that has possibly formed. Can you see this crack? This is shown from the paper, from the aspect of paper, that is 2D, though 3D processes are taking place. So what is happening? Let us say certain cracks develop. Right? Now, see here. In order to understand this, you need to understand two phenomena. So, joint fractures in the crustal rocks wherein no appreciable movement take place. Now, let us assume these cracks that have formed are like joints, because right now there is no movement taking place. Again, see, let us take a little more. Cracks are formed within this layer. There is no movement, it is like this only. Now what happens is, if supposingly, let us assume this further, let us say, cracks widens. This crack further widens. And supposingly there is, let us say, bending of this particular part. Right? Because it started from a joint or a fracture, and now what is happening? There is some movement that has taken place. Now, when the movement takes place, then it is known as a fault. When the fractures in the crustal rocks wherein no appreciable movement take place. There are cracks that have developed, but no specific appreciable, noticeable movement has taken place, because these are merely joints. But when you see that there is further aggravation or intensification of this process, when there is an appreciable displacement of rocks on both sides of the fracture parallel to each other, in that particular case, you will see it is known as a fault. This is again a very, very important phenomena which you will be studying now. Now, before you go ahead, there are certain things that you need to analyze with respect to fault. These concepts will be clear. Now, let us assume, let's see this. Supposingly, this particular block was earlier over here. Let us assume this. Let's see this. Earlier, this block was at this level. Right? Let us assume this. It was at this level. Now, due to the various forces, it has moved down. Clear? This block has moved down. This is the fixed part. This is, let us say, this part is fixed. Now, the block which has moved down, that means this is known as a down thrown block, represents the lowermost block in a fault. First thing. This part is known as the upthrown block, represents the uppermost block of the uppermost part of the block of the fault, of the fault. So now the one which has gone down, which is the, let us say, which is representing the lowermost part will be known as a down thrown, which is the uppermost will be known as the up thrown block. Now see here, the line, this line do you represent? This is a line through which basically this movement is taking place. This is known as the fault plane. Along the fault plane, this particular part which is associated with the movement of the block that is taking place, this wall will be known as what? The hanging wall. Why hanging wall? Because this is a block which is moving down actually. So this is known as the hanging wall. Now this which is stagnant over here, this is known as the foot wall, this part. This is what? The hanging wall. And this is taking place along the fault plane, right? Block below the fault plane is known as a foot wall, and this is basically the hanging wall, block above the fault plane, right? Now see, this part where it was originally located, this has moved down. So this is the part which has now been empty because the block has moved down. This is known as the steep wall, like slope caused by the faulting. So this slope that is formed because of the faulting processes and the block that has gone down, this is known as fault scrap. So this is a steep wall that is formed because of faulting phenomena. These are those concepts which you should understand very well, because this basically helps you to analyze the various types of faults that are present. Clear? Now these are, again, one more thing, this angle, the horizontal, the angle between this, the horizontal plane and the fault plane. This is what? The fault plane where the faulting is taking place. This is what? The horizontal. The angle between them is known as a dip angle. This has also been asked in civil services, in PCS, so every time they ask this phenomena, particularly these things. You should be well aware of this. Okay, let's move ahead. Let us see the types of faults. There are various types of fault: normal fault, reverse fault, lateral fault, step fault. Graben or rift valley are sometimes considered as an outcome, but some books put it as a type, so that is why I mentioned here. That is why you will see a lot of rift valleys that are present, Narmada, Rift Valley and all. They are basically formed because of these phenomena only, right? Let's see. Normal fault. These are caused by the tensional forces. What do you mean by the tensional forces? That means forces or diverging forces are being exerted. Now these diverging forces tends to pull the crust apart. Obviously, it is going to pull the crust apart. And also by the forces that tend to expand are pushing. So by that means what happens that this tensional forces create a fault, and this part might move down. Now this is known as a normal fault. On the other hand, if there is compressional forces, let us assume, if there is compressional forces taking place, because of this compressional forces, this front fault plane that is created, it leads to this part going down along this along this fault plane. This is known as a reverse fault, formed due to the movement of both sides of the fracture towards each other. So normal plane is associated with tensional forces. Reverse fault is associated with the compressional forces, and this is how and what the phenomena basically take place. Lateral fault, in which you realize that these two blocks are sliding along with each other. So these are formed because the rock blocks are displaced horizontally along the fault due to horizontal movement. So they are basically sliding along each other. Clear? Step fault. Now step fault is very interesting, where you see a step-like structure is formed because of the various faulting activities. Certain books only mention these three types of faults, and they represent the step fault and rift valley as the outcome. Please understand them. Certain books mention rift valleys and step fault as an outcome of these faulting activities, but certain books mention as a type of form only of fault. So we have mentioned it here. There is no problem in that. A series of fault occur in any area in such a way that a step-like structure is formed. So this is known as what? Step fault. Along these lines, see, these are the fault planes through which these step-like structure is formed. Graben or rift valleys, these are the major relief features resulting in the faulting activity. It represents a trough depression on the basis of the crustal path. So what happens is, let us say between these two parts, let us say this part has gone down. So this is representing a depression, and this is representing like a risen part. So these are known as rift valley structures. Clear? That is why you see Narmada Rift Valley. Yes, and the river is basically flowing through these graven regions. These are also formed due to the faulting activities. Clear? Okay. Now coming back to the, we have done with the faulting we have done with the endogenetic aspects. Now let us come to exogenetic. Now see, as I've already mentioned, we'll be covering weathering and mass wasting over in this chapter. We'll be covering a few definitions over here because this has to be covered in the next chapter. Let's start with the weathering aspect. Now before we start, let us understand these are processes: weathering, mass wasting and erosion. Before I begin, you should be very clear about this. When I talk about weathering processes basically tend to loosen the fragments of the rocks. Now, they are done by physical processes, biological processes, chemical processes, and obviously gravity also plays a role, which we'll be analyzing. Mass wasting or mass movement is only associated with a gravitational force. Sometimes people say, sir, if something is moving down because of running water, when I talk about running water, then I will not cover it under mass wasting. Anything over here, and the only force that is associated with mass wasting is gravitational force. Anything moving under the force of gravity, that is mass wasting. Erosional obviously is associated with kinetic energy because you realize that river water, let us say, eroding certain things, waves eroding certain things, glaciers, avalanches eroding certain things, those have kinetic energy. And that is where the erosion is taking place or removal of fragments are taking place. That is associated with erosion. Mass movement or mass wasting will only be associated with a gravitational force. Please mark this and keep it in your head before we move ahead. Clear? Okay. When I talk about weathering, let us start with the process of weathering. Weathering is a process of disintegration and decomposition of the rock in situ. In situ means at the place where the weathering is taking place, over there only this decomposition is taking place. Right? So disintegration, a rock fragment is there, it is broken down, decomposing, broken down into further fragments. Whatever be the process of disintegration and decomposition of the rocks in situ. In situ means at the place where it is situated, it is taking place over there. That is why in situ. It is through the mechanical and chemical changes in the rocks. Yes, though whatever be the processes that are acting on it, physical, chemical, biological, but it is basically leading to some mechanical or chemical changes. That is why weathering will take place. Right? Even if, let us say, biological action by some animal or someone is scratching a rock and there is some breaking of the fragments, though done by a, let us say, an animal, still a mechanical force is being exerted. So that is why we are talking about mechanical and chemical phenomena. So let us say chemical because let us say some chemical reaction taking place. That is also possible, which we will be seeing. There is no movement of weathered material unless under the influence of gravity. That is why we have said if any movement is taking place, it might be due to gravity, but we will, under weathering, we do not consider any movement of the substances taking place because that will come under when we will be studying the topic of erosion and transportation and all. Under weathering, always remember that there is decomposition and disintegration taking place at the place where it is. And if certain appreciable movement is there, that will be because of gravity, not because of any other geomorphic agent like running water or wind or anything else. No. If there is some movement because of gravity, otherwise no. That is the core concept that you should remember. There is no movement of weathered material unless under the influence of gravity. So these are statements which are asked in the civil services also. These are very important. Now you will say why they have considered this, not other processes. Please understand these are standard phenomena through which they have differentiated what processes will come under what category. Otherwise, everything will overlap with each other, then you will not be able to differentiate between them. That is why they have made these rules with respect to the definition and the concepts. The movement of weathered material under the influence of gravity is called mass movement. Now, please understand how weathering and mass wasting are association over here. Weathering is the decomposition and disintegration of the rocks or the minerals in the rocks over here. Now, this decomposition is what weathering. When I talk about over here, the movement of these weathered material under the influence of gravity is mass wasting or mass movement. Can you understand this? So that means under the weathering concept, they said you can include the concept of movement under gravity. So mass movement is in a way part of it, where you are basically talking about the movement of the weathered material if taking place under gravity would be mass movement or mass wasting, which is already a part of weathering. So this is very, very important. We will be doing mass wasting and weathering. Again repeating, let us assume there is, let us assume this. This is possibly what? A huge rock that is present in a desert region. Let us say the regions of Persia, Iran, Iranian deserts, a little rocky deserts also, you know that. Now because of this, lot of, let us say, winds are moving around. And because of that, let us say outer layers would be, let us say, little bit eroded. Again, there is high temperature during the daytime, cool during the night time. So obviously those factors are taking place. Let us assume now certain erosions are taking place. Certain weathering is taking place, not erosion, weathering. Now what is taking place? You see this? This is disintegration of this particular aspects. Now you will say, sir, the finest sediments that are basically being weathered are falling down. Now those falling down is basically under the influence of gravity. Clear? So when I'm talking about weathering, I'm talking about the decomposition and disintegration that is taking place of the rocks. Any movement that is associated of the weathered rock under the influence of gravity is mass movement or mass wasting. This should be very clear. Because when I will talk about the transportation and all those phenomena taking place due to running water, waves, currents, winds, that will come under erosion, not under these phenomena. Weathering basically loosens up or disintegrates, decomposes. Clear? Okay. Now let's move ahead. Movement of weathered material under the influence of gravity is known as mass movement or mass wasting. Weathering aids mass movement as well as erosion. Obviously, erosion later on will take place, will be held because it is weathering processes are loosening what? The fragments of the rocks. Weathered rock matter is known as regolith. Now, the weathered rock material is known as regolith that basically forms a basis for the soil. Obviously, later on you form the soil. So, we will be seeing these aspects also later on. So, what is this weathering? Process of disintegration or decomposition taking place of the rocks in situ. That means at the place where it is. Secondly, this is because of the mechanical and the chemical forces or phenomena that are happening or changes taking place in the rock. One, you should also remember there is no movement of the weathered material unless it is, and we are talking about the force of gravity. And the movement of the weathered material under the force of gravity is known as mass wasting or mass movement. Clear? Let's move ahead. Types of weathering, it is mechanical or physical, it can be chemical, it can be biological. These are the three major types and these are the broad phenomena under which we are going to study. So let's see the first category, which is basically what? Physical. Now what I mentioned over here, these things are mentioned in our NCERT in one line and they're not been explained properly also. So what I have done over here, I have mentioned that I made the diagrams, mention them in detail so that you understand them properly. You will not require anything else beyond this. Mechanical weathering or physical weathering. These involves mechanical lock disintegration caused by temperature and pressure fluctuations. And because of that, weathering is taking place. There are a lot of types, ways through which this physical or mechanical weathering can take place. Let's see one by one. Block disintegration due to temperature change. Now see, let us assume this is the original rock that is present, right? The block disintegration refers to the effect of temperature on different rock types like expansion and contraction in granite due to temperature variation. Now let us say this is a granitic rock and lot of outside temperature variations are taking place, because of which a major part of block basically falls down under the influence of gravity over here. Because why? There is, during the daytime, let us say temperature is high. Then there might be cooling effect during the night time. So there will be, let us say, a disintegration or cracks might develop on these rocks and a huge, large broken block will fall down. Now, you see these lines that I have made, these are because of the cracks that are made due to contraction and expansion. During the daytime, when there is a lot of heat, temperature is high, expansion of rock will take place. During the night, when there is cooling, so that means due to repeated expansion and cooling, there will be cracks that will develop. And a large, huge piece of rock will break from this major peer-edged rock, and this is known as block disintegration due to temperature change. Clear? Block disintegration due to temperature change. This is first type. Second, granular disintegration due to temperature change. Now see, both these phenomena is basically majorly varying because of the different in the type of rock. Because over here also, if you see, there is going to be temperature changes, let us say heating during the daytime, cooling during the night time. That phenomena will take place here. But why certain block is being broken down here from the parent rock, and over here granular disintegration means small finer particles falling down? It is because of the variation in the type of composition of this particular rock. Now see, that is why coarse grained rock are more affected by shattering processes in the hot desert, which are characterized by high range of temperature. So those rocks which are very highly, let us say, coarse grained, there is greater probability of them undergoing the phenomena of granular disintegration. Now we'll see what it is. If rocks are coarse grained and are of different colors, because it is coarse grained, possibly there are a lot of different colors or subparticles that are present, they will be absorbing light also to a different degree because of the color, and that will basically lead to the absorption of light in a differential rate, and that will lead to a lot of particles basically separating or falling from the parent rock. Now if you see this particular yellow line, this represents the original or the former rock substance that was present here. Now because of the heating during the daytime and cooling during the night time, unlike the previous one where the block fell, over here, because this is coarse grained, small particles of these rock will basically fall down. That is why rock disintegrates into small granule sized particles, often resembling a coarse sand. So that is why this is known as granular disintegration. Again, the conditions might be very similar in case of the block disintegration and granular disintegration. The only difference majorly will be because of the type of rock, the composition of the rock, and the texture of the rock. That is what is making the difference here. Okay, let's move ahead. Block disintegration due to frost. Now see, disintegration of rock into large sized blocks due to freeze and thaw of water, common in the temperate and the cold climatic regions. Let us assume this is a original piece of rock. Now there is a crack that is present here. Let us say during the daytime and temperature relatively little warmer, water might enter this. Now during the night time, the water might freeze, because when the water, you know that very well, when water converts to ice, it expands. This expansion will lead to the pressure being exerted on these, the rock substance. The crack will further widen. During the daytime, the ice will melt again, and this water will again move even deeper. The same process will repeat day, night. What will happen ultimately is, it will lead to these two, this whole mass basically being split into two or more parts. That is why it is also block disintegration, because big, huge particles are being separated rather than small granules. So that is why block disintegration due to frost is taking place. These take place in the temperate or the cold climatic regions where water can freeze naturally also in those regions. So that is why this is one of the major forms of erosions physically when you see in the cold or the temperate regions, right? Let's move ahead. Exfoliation due to temperature and wind. Now over here, temperature and wind are playing a very important role. Now see here, exfoliation weathering is also known as onion weathering. Very important concept. This has been asked in your preliminary examination and repeatedly in the PCS examinations. Please remember this. It refers to the peeling of a concentric shells of rocks. What do you mean by peeling? Like onion has so many layers, you keep on peeling one or the other layer. Similarly, over here, the similar phenomena is happening. So the peeling off of concentric shells of rocks due to the combined action of heat and wind in hot, arid and semi-arid regions and monsoon land. So what is there? Let us see. Let us say this is a granitic rock where during the daytime a very high amount of intensity of, let us say, heat is being generated. Over here, it will lead to expansion of the granitic rock. Now what will happen is, now these over here, the role of wind is also very important. During the night time, the contraction will take place. This will lead to development of cracks. Then again, what will happen? Next day, again during the daytime, it will lead to, let us say, certain parts again expanding, because of which, let us say, a layer of this layer of the outer layer will basically remove because of the wind also, because the wind will also act on it, and along with the temperature variation and development of cracks. And what will happen is, wind will further remove all these small fragments that are outside. It is like peeling of the layers. Now this remaining part is known as the exfoliation dome. This is known as onion weathering, because with time after time you will realize the outer layer being subjected to the temperature variations during the day and the night, and the wind is exerting an important influence where those layers where the cracks are developing, it acts as a force for further disintegration, and that leads to slowly the outer layers being removed and the size keeps on decreasing, and finally it will be non-existing. This is known as exfoliation due to temperature and wind. This was the physical weathering. Now let us come to the chemical weathering. Now please understand. Note this heading quickly that is associated with chemical weathering. Please note it down. Now see, decomposition or disintegration of rocks due to chemical reactions is known as chemical weathering. Now this is because of the chemical reactions. Now please understand, over here you do not have to go into a lot of detail. I'll be covering in them what is required over here. Various books mention various types. So I've covered comprehensively over here what is required by you. So stick to this. Solution. Now, what do you mean by solution? See, it refers to the dissolution of soluble particles and minerals from the rock with the help of water and acid. Now, there are a lot of minerals that are present in the rocks which are soluble in nature. Some directly in water, some let us say some in acidic form, let us say water reacting with carbon dioxide, creating an acidic nature, and that might lead to certain minerals dissolving in it. So what is that? That is basically known as solution. That refers to the dissolution of soluble particles and minerals with the help of water or acids. Now, on coming in contact with water, many solids disintegrate and mix up in the suspension in water, right? Soluble rock forming minerals like nitrates, sulfates, potassium, etc. are affected because they are soluble in nature. They were the ones going to be impacted by this. So what happens is, when these rocks basically come in contact with water which are soluble in nature, they will dissolve. Yes or no? They will dissolve, and obviously they will be then washed away. That is why if you see examples, minerals like calcium carbonate and calcium magnesium bicarbonate present in limestone are soluble in carbonic acid. Carbonic acid is basically formed by the reaction of water with carbon dioxide. It leads to the formation of this mild carbonic acid, which basically dissolves what? Calcium carbonate and calcium magnesium bicarbonate. Now please remember this. This particular case is basically representing carbonation. Carbonation over here is not a separate phenomena. It is basically an example of solution. Certain books do not even mention carbonation. Why they do not mention? Because they consider because it is already a part of solution, but some mention. That is why I mentioned here. So it is a reaction of carbonates and bicarbonates with minerals in a common process in breaking down of the feldspar and carbonate minerals. So what is going on is, this particular example which I mentioned here is itself a representation of carbonation phenomena. So this is an example for solution, but this is itself a process of carbonation. So that is, a carbonation is also a type of solution. If you want, you can mention it. You do not want to mention it separately, there is no problem. You will not be marked wrong. So over here, carbonates and bicarbonates with the minerals over here basically react with carbonic acid and then dissolve. And now this phenomena is known as carbonation. Now it is a form of an example of solution or type of solution. So you can mention it separately also or part of solution also. There is no problem. Next, hydration. Hydration is a chemical addition of water. Now what happens is, let us say, let's take an example also here. Minerals take up water and expand. This expansion causes an increase in the volume material itself on the rocks. Let's see, calcium sulfate reacts with water to form gypsum. Calcium sulfate dot 2H2. This is gypsum. So what is this? It is a chemical addition of water to calcium sulfate. Now I'm using the chemical reaction. Many will say that we do not know. Please remember this. This is a the basic science which even a class 10th level should know, because this is part of your general science also. So this is what? CaSO4. What is this? Calcium sulfate reacting with water to form CaSO4.2H2O. Yes. So this is known as gypsum. So this is chemical addition to what? Chemical addition of water to basically calcium sulfate. Please note it down. Clear? Okay. Oxidation refers to the reaction of atmospheric oxygen to form oxides. Now, addition of oxygen to, let us say, to form oxides, what will happen? Let us say iron is reacting with water and oxygen. It forms Fe2O3 plus 3H2O. This is basically rust. This you have done in class 9th and 10th also. So what is happening over here? It is basically forming oxides of certain elements or minerals. So this is resulting in what? The process of oxidation, where addition of atmospheric oxygen is taking place, resulting in formation of oxides. Clear? Like ferric oxide. Similarly, other oxides are also formed. This is oxidation. Now, these basically lead to what? Breaking down of various rocks, and that is why it is also a form of weathering. Now, come to biotic weathering or biological weathering. Now, biological weathering is geological processes in which organisms like plants, animals, and humans or microorganisms basically contribute towards disintegration or decomposition. Now, under the category of animals, we include humans also for that matter, right? So, all the processes of disintegration taking place due to plants, animals, other microorganisms, humans comes under biotic weathering. Let us say burrowing organisms. Animals like burrowing organisms like rodents, insects, earthworms can create tunnels and burrows in the soil, rock. Their activities result in physical disruption of the rocks and sediments. So obviously these burrows basically lead to disintegration of various rocks. So that is also caused by what? Burrowing organisms or animals. Microorganisms like fungi, bacteria, lichens are microorganisms. They produce organic acids. Now, these acids are chemically they might dissolve certain minerals. That also leads to what? Disintegration of the rocks. Next, plant roots. As the roots grow further, they exert a lot of pressure. So now they exert pressure on the surrounding rock, causing it to crack and break apart. Now, these are also what? Types of biological weathering. Now, let's come to another topic, that is mass movement and mass wasting. I had told you something. When I talk about mass movement, that means there is some movement of what? The weathered material, but only under the influence of gravity, not because of any other force. Remember that very, very well. See here. Mass movement transfers the mass of rock debris down the slope under the direct influence of gravity. So there is some downward movement. So that means there has to be certain influence of gravity, only then this will take place. So weathering is not a prerequisite for mass movement, though it aids the mass movement. This is again a very, very important dimension. Weathering is, what does weathering do? Weathering basically disintegrates the rock. It is not necessary that disintegration has to always take place. If supposingly there is a rock that is present on a slope, now there is no disintegration taken place, still it can move down because under the influence of gravity. Yes? So that is mass movement or mass wasting. Yes, if the rock is present there and it has undergone certain disintegration, that can basically be aided, that will basically be helpful. It can move down because of that also, but it is not necessary that weathering always has to take place. So weathering is not a prerequisite. Mass movement is aided by gravity, and no geomorphic agent like running water, glacier, wind, waves, currents participate in this process of mass movement. Remember that mass movement is only the movement taking place because of gravity. No other phenomena like running water and all those things will come under this category. Because that is why can I say mass movement does not come under erosion, because under erosion we include all these factors of winds, glaciers, currents, winds and all those things. So mass movement does not come under erosion. That is clear cut. These are statements which will come as statements in your preliminary examination also. So if I see the major classes of these mass movement, please understand some of them are very rapid movement. That means no water is required here. Let us say landslides, under which you have slump, debris slide, rockfall, rock slide. We'll be doing them, don't worry. Rapid movement, that means slower than these phenomena. Though over here you require enough water is required. Earth flow, mud flow, sheet flow, avalanche. Slow movement, little water is required, creep and solidification. Now you will be seeing, sir, ki over here the movement is under gravity. Movement is under gravity, please remember that. This should be very clear. Whether certain agents are aiding or not aiding a different phenomena. Please understand, geomorphic agents might be helping, but the movement will take place under gravity. That is a major phenomena. Please understand this very well. This is somewhat confusing when you read the books. Geomorphic agents might aid, but the movement will take place under gravity only. That is why it will be considered under mass movement. Very rapid movement over here. These are relatively rapid and perceptible movements. The material involved are relatively dry. Under them, very rapid movement, you have slump, debris slide, rock slide and rock fall. These are the four. Let us see one by one. See here, slipping of one or several units of rock debris with a backward, this is important, backward rotation with respect to the slope is known as slump. Do you realize something? Over here, this is moving down, but there is a backward rotation. It is rotating. This backward rotation is basically referring to the slump. If there is no backward rotation and simply, let us say, the rolling and sliding movement is taking place without any backward rotation, it is known as debris slide. Again, slipping of one or more several units of the rock debris or debris with a backward rotation, it is backwardly rotating, then it is known as a slump. If all the phenomena are same but no backward rotation is taking place, then it is known as a debris slide. So rapid rolling or sliding without any backward rotation is known as a debris slide. Over here, simply moving down without any backward rotation. Next, rock slide. Sliding of individual rock masses down the bedding joints is known as rock slide. So let us say there is rocks were here under the impact of gravity. They are basically moving down. This is known as rock slide. Supposingly a rock is over here. It has fallen down. This is known as rock fall. Rock fall is free falling of rock blocks over any slope, keeping itself away from the slope. So obviously, in a way, sliding is again moving down the slope. Over here it is falling because of possibly the inclination that is there. And obviously, please remember, it is a free fall, free falling of the rock blocks over any steep slope, keeping itself away from the slope. Right? Let's move ahead. Rapid movement, earth flow. Now these are relatively present in the humid climatic conditions. The movement over here, whether there is, let us say, saturation of water or not, movement is because of gravity. Remember that very well, right? Geomorphic agents might aid, but the movement is going to be under gravity. Earth flow, the movement of water saturated clayey or silty earth material down the terrace or hillside is known as earth flow. If you see here, water saturated clay and silty soil moving down the slope is basically known as earth flow. What is mud flow? Absence of vegetation and heavy rainfall, thick layers of weathered material get saturated with water and flow rapidly. Now, because again mud will have a large amount of weathered material also, so this is basically moving down the slope. Debris avalanche, again it is similarly, please remember, it is a larger form of a mud flow. The reason behind it is, you can say, when we talk about avalanches with respect to glacier, those are very large scale, very relatively faster moving. Similarly, you can say it is a larger version and a faster version of a mud flow. That is why it is more characteristic of humid region with or without vegetation cover, occur in narrow tracks on steep slopes, much faster than the mud flow. Clear? Slow movement. Now, creep over here and solidification I mentioned. These are again slow movement processes that take place. Creep is again occurs in moderately steep, soil covered slopes. Movement of the material is so slow that it is not even perceptible normally. You will see, let us say, the movement of the soil is basically moving down. So this is known as soil creep. Example is soil creeping. Over here, you will not be able to observe through your naked eye. It is so slow. But obviously, if you observe it over a very long time, you will see that this particular slope or this soil is basically moving down. Let us say the tree is here, possibly after a long time, it might be here. So now is solidification. Solidification, what happens is a slow downward flowing mass of fine grained rock debris, which is saturated with water. So this is saturated with water, the underlying, and because of that, this particular fine grained soil, or let us say, is moving downward. So this is known as solifluction, because solifluction is associated with saturation of what? Water, which acts as a lubricant for it to basically move down. Clear? Please note it down. Erosion and deposition, please understand, we will be covering this in the next chapter. It basically involves the acquisition and transportation of the weathered material or the rock debris, and it is basically the application of kinetic energy associated with the agent. Now please understand, whenever we talk about erosion, we will be considering the aspect of kinetic energy being associated, where geomorphic agents like running water, waves, currents, winds and all are acting on the substances which are either weathered, because weathering helps or aids in erosion. So, and what are the processes that are associated with them? So we'll be considering them in erosion, because erosion has to be studied comprehensively from the erosional aspects and the depositional aspects. So if a wind is eroding certain thing, it is going to deposit also. So those deposits that take place are known as the depositions. It is a consequence of erosion. So these are two phenomena which will be studied in the next chapter in the topic of landforms. So I've just mentioned it here just for your knowledge. So this was the topic of geomorphic processes. Hopefully you enjoyed it. Hopefully you studied and understood it. Please go through the notes and content repeatedly. You will be able to understand it better, because this topic is a little complicated also. This requires revision. So God bless you. Take care. Happy Diwali to all of you. We'll be coming with the next lecture after Diwali. Lots of love from my side. Keep on listening to these lectures, understanding them, and note it down and understand and memorize them after understanding. So God bless. Take care and Jai Hind.